This video is about sec, cosec and cot. Whenever we do the reciprocal, whenever we do 1 over cos, sine and tan, whenever we do 1 over them, we get 3 new trig functions. So 1 over cos theta is equal to sec theta. 1 over sine theta, we call that cosec theta. And 1 over tan theta, we call that cot theta. A good way of remembering which one's which is to look at the third letter of sec, cosec and cot. So the third letter of sec is a C, and that is 1 over cos theta. The third letter of cosec is an S, and that's 1 over sine theta. And the third letter of cot is T, and that's 1 over tan theta. So 3 new trig functions we've got here, and they're made by doing 1 over cos theta, 1 over sine theta, and 1 over tan theta. So let's look at using these now. So if we had to find sec 40, we just change it back into terms of cos. So sec 40 is equal to 1 over cos 40. So we can't type sec into a calculator, but we can type 1 over cos into the calculator. So we make sure we're in degrees, and we can just type 1 over cos 40 in this case. And to 3 significant figures, that's 1.31. Okay, same thing for cosec. So we can't type cosec into a calculator. So cosec 78, we can't type into the calculator, but we just use the fact that that's 1 over sine 78. So we type 1 over sine 78 into the calculator, and that's 1.02. And cot 1 radian, so cot 1, make sure the calculator's in radians this time, is 1 over tan 1. And to 3 significant figures, we've got 0.642. Okay, so here's 3 more of those. Pause the video, give them a go, and then press play to go through the answers. Okay, so if you want to find sec 27, sec 27 is equal to 1 over cos 27. So the calculator's in degrees, 1 over cos 27, that's 1.12. Find cosec 0.5 radians, so switch back to radians. Cosec 0.5 is equal to 1 over sine 0.5. And that's 2.09 to 3 significant figures. And finally, cot 38 degrees. So cot 38 is equal to 1 over tan 38. And that's 1.28. Okay, so let's look at the graphs of sec, cosec and cot now. So sec first. So we've got the original graph here, which is y equals cos theta. And we're going to draw the graph of sec theta. So the first thing to point out is that wherever cos theta goes through 0, we can't divide by 0, so we get an asymptote. So wherever the cos graph goes through 0, we have an asymptote. Then wherever the original graph, wherever cos theta is at 1, 1 over 1 is 1, so sec theta is also at 1. So all these points, sec theta will be at 1. Then as cos gets smaller and closer to 0, sec theta will get bigger and bigger. So what we end up with are these kind of U and N shapes coming off the top and the bottom of the cos graph. And wherever we have a minimum for cos, that's a maximum for sec. Wherever we have a maximum for cos, that's a minimum for sec. And it just forms this pattern like so. The cosec graph is almost exactly the same, just shifted across. So wherever sine theta goes through 0, we have an asymptote. And wherever we have wherever sine theta is 1, cosec theta is also 1. And whenever sine theta is a maximum, cosec theta is at a minimum. And wherever sine theta is at a minimum, cosec theta is at a maximum. So it just follows the same pattern, making these U and N shapes off the maximums and minimums of the original graph. And cot theta finally. So again, wherever tan theta goes through 0, we get asymptotes. So every 180 degrees, we have an asymptote. And then wherever tan is positive, we want cot to be positive. And as tan's really small, cot's really big. So it comes almost in the other direction to the tan graph. Whenever tan's got an asymptote, it goes through 0 and then flicks around the other side. So it follows the same pattern as the tan graph in the other direction. Something like that. Okay, now we're going to look at solving some equations using these new trig functions. So we've got cot x equals 2. And we're going to solve that between 0 and 360. So again, we can't type cot into the calculator. So we're going to change it. And we're going to change cot, third letter's t, we're going to change cot to tan. So we've got 1 over tan x equals 2. So rearranging this, 1 equals 2 tan x, or tan x equals 1/2. So tan x equals 1/2. So we're going to shift tan, we're in degrees, get x by itself. So shift tan 1/2. And we get 26.6 through significant figures. We want the answers between 0 and 360. We know tan repeats every 180 degrees. So if we just add 180 onto our answer, and that'll be 206.6 to 1 decimal place this time, or 207 to 3 significant figures. Okay, solve sec x equals 3. So we're going to change sec to cos. So 1 over cos x equals 3. And then we can rearrange that to get cos x equals 1/3. So you could think about that as flipping over both sides or multiplying by cos x and dividing by 3. Either one of those. But we'll get to cos x equals 1/3. And we're going to shift cos 1/3. But we're in radians this time. So we want the answers between 0 and 2 pi. So shift cos 1/3 but make sure you're in radians. And we get 1.23 to 3 significant figures. Because we're in cos, to get the next answer, we're going to do 2 pi minus the first answer. So 2 pi minus the answer, and to 3 significant figures, that's 5.05. Okay, solve cosec 2x equals 5 between 0 and 360 degrees this time. So we're going to change cosec to 1 over sine. So 1 over sine 2x equals 5. And that means sine 2x equals 1/5. So we're going to shift sign 0.2 or 1/5, making sure we're in degrees this time. So 2x equals 11.53695,903. Going to keep the whole number because we're going to be dividing these answers by 2 this time. So either store it in your calculator or keep the whole number. To get the second answer, we're going to do 180 minus the answer because it's sine, so 180 minus the answer, so 168.463041. And we want 2 lots of answers because we're going to have to half them. So we're going to have to go around twice. We're going to have to get the next 2 answers as well. And we're going to do that by adding 360 on to these answers. Because the sine wave repeats every 360. So that'll be 371.53695,093. And 528.463041. And now we're going to half these answers. So divide them all by 2. So the first one divided by 2 to 1 decimal place, 5.8. The second one divided by 2 is 84.2. The third one, 185.8. And finally the last one, 264.2. Okay, here's a couple of questions for you to try. Pause the video, give them a go, and then I'll go through the answer after. Okay, so the first one, we've got cot x equals 4. So we're going to change cot to tan. So 1 over tan x equals 4, which means tan x is 1/4. We're in degrees, so we're going to shift tan 1/4. Shift tan 1/4, and that's 14.0 to 1 decimal place. And we're in tan, so it repeats every 180 degrees. So if we add 180, that's 194.0. And those are our 2 answers. Second question, solve sec x equals 2. And we're in radians this time. So sec is 1 over cos. So 1 over cos x is 2, which means cos x is 1/2. So we're going to shift cos. Shift cos 1/2. And that's 1/3 pi. So 1/3 pi. We're in cos, so we want to do 2 pi minus the answer. which gives us 5/3 pi. And those are our two answers.